What's up guys, Upward here and this is Whilelab YouTube channel. Here we are with day 15 of 30 days of code, and today's video is about linked lists. What are linked lists? Okay, so let us jump into the challenge. As you can see here, the following import is handled for you by the locked code in the editor. The first line contains t, which is the number of test cases. The t subsequent lines of test cases each contain an integer to be inserted at the list's tail. So each number of those except the t will be inserted at the end of the list. So first the list would be empty, so we would insert 2, it would be the last thing. Then we will insert 3 at the tail of the list. Then we would insert 4 at the tail of the list. Then we would insert 1. So it would look something like this. So as you can see here, first the head would be the 2 and it would be the tail also. How do you know if it's the tail? Ends with this null means there's nothing after it. I'll explain in a moment, just let us finish this. Okay, then we'll insert the data 3 into the tail of the list. So it would be then now 2, which is the first node, would point that the data 3 is after it. So now the length of the list is 2 integers, and the 3 or the node 1 points to nothing. Then we'll add 4, then we will add 1. So it will start with 2, we'll add 3 to the tail, then we would add 4 to the tail, then we would add 1 to the tail. But what are the difference between the normal list, the array that we use in Python, and this linked list? So the difference is that this is a singly linked list. What does that mean? Okay, so the difference between singly linked list and doubly linked list, okay, that you will start with this node. Okay, every item is a node in the linked list. Now this node has 3 types of data if it's doubly and 2 types of data if it's singly. So in the singly one, it has the data in it, okay, and it has identified the first item as the head. So for example, if this is the first item in the list, it will be called head, okay, and would have the data in it. This node has the data as 2, and it would have a pointer to the next node. So this has the data to the next node, which is 3. So then in the 3 you have 2 types of data, the data in it, which is 3, and what node is after this node. If it's for example here, it would be 4, okay, or this node. So then this node has 2 types of data, the next node and the data inside this node. So the data inside this node is 4, the next node is 1. Great. In 1 it has 2 types of data, the next node, which is null, so that means this is the last item in the list, and the data in it, which is 1. That's in a singly linked list. In a doubly, you would have also the previous data of the previous node. So for example, in the 3 here, you would have the data that points to the next node and the data that points to the previous node, so you can navigate forward and backward. Hope that's clear. So what is the difference between singly linked list and normal list? As you can see on the right side, the normal list has indexes. This also has indexes, but in the memory those does not have to take like in a normal array or in a normal list, you would have to define the list, how many items beforehand. Now in Python it's a dynamic, so you don't have to, because the programming language itself takes care of that. But in a more lower level programming language, or in general, you would have to define how many items you are going to put in the list. So why is that? Because it would like lock on those this space in the memory for this list, and you can navigate by indexes. So you can say, for example, bring me the index number 2, and it would give you 4 instantaneously. But in the linked lists, there is no indexes. You would have, if you want a number, so for example, if you want to get the 4, you would have to go from the 2 to the 3 to the 4. So you'd have to go through every single node to find out what its value, and if this value exists. So you can't navigate, just jump in right into the index like you would do with normal list. Now this has different purposes that I will not discuss in this video, but you can look it up. But in general, it has its benefits and its downsides, and the normal list has its pros and cons. So yeah, like anything in life. So yeah, the task is that we should complete the insert function in your editor so that it creates new node, pass data as the node constructor argument, and insert it into at the tail of the linked list referenced by the head parameter. Once the new node is added, return the reference to the head node. Okay, so as you can see, I've solved it. Let me reset. So let us reset. Okay, so the most important thing they want us to do is create, basically add the data that will be passed over here. As you can see, the t, okay, will be a list of integers. So we want this data to be converted into a linked list like this one. Okay, so how are we going to approach this? First, as you can see here, there's a class called node. Okay, now this class node is basically represents the node in a list like this one. So this is a node. What we'll do is implement this insert method, which what it would do basically is insert a node to create a linked list, a singly linked list. So let us see how we will approach this. So first thing you will notice over here is the function, or the code that will be executed first would create a mylist, which would be a solution instance, okay, an instance of the solution class. Then this t will get the numbers from the input. Then we have the variable head, which would be none. Then it would loop. Now this is the default code. So then for I in range of t, the number, which the first number we will get, we will create a data based on the numbers in t. So as you can see here, this will be 4. Okay, so then it will create the data based on those 4 numbers. So it will create the data based on those 4 numbers and stores them over in this data variable. Okay, then it will pass to the mylist, which is an instance of the solution class, and we'll call the insert method that we will be creating, and it would pass head, as you can see here, and data. Now in the first run of the for loop, head will be none, okay, and data will be the number, okay, the first number, which is the 2. Okay, so let us work on that. Now if the head is none, that means we want to set the head to be the first number we will add, which is the 2. So how will we implement all of this? First thing, we'll create a node and call the node method, okay, store the node and create a node instance of the node class, and we'll paste the data that we will get, which would be 2 at first. Then the first thing we want to check is if head is or equals, or both works, is none. If the head is none, then return head. Okay, no, return node. Okay, so if the head is none, then return node. That means we will return the node that we just created based on the data. So it will pass to this data p2. It will be passed here. The head is null. Okay, as you can see here, the head is none. So head is none. Okay, so this will be true. So it will return the node. Now the node is an instance of the class node with the data in it, which is 2, so it will be returned and will be stored in the head variable. Now in the second round with the 3, it will come and check. Okay, so we've got data. What is the data? We've got 3, man. So head would be now 2 and the data would be 3. Now what we want to do is add this 3 into the list, so we will do else. Now this else is for the second run, so else, or so if head is not none, that means we've got a number. Now what we'll do is make our current, okay, equals current equals head. Okay, so our current variable will equal head, which is the 2. Then we will make a while loop, while current dot next, as you can see. So this would call the next variable over here. So we want to check is there is something after the head. Okay, so while current is dot next is not none, then current equals current dot next. So we will keep moving to the next list, because as we've said over here, with the last node, the pointer to the next node would be null or none in Python. Okay, so if it's not none or null, if it's not empty, in other words, that means there is a node after it. If there is node after it, then make current points to that and check the one after it. Okay, so then make current dot next equals node, which is the data we have over here. Okay, which is the data we've got. So now we will create 3. So it would go to 2, then it would find it's null. Okay, or that it's empty. Then after the 2 there's an empty or a null. So if it's null, okay, it's gonna break out of the while loop and come here and add next, and it will create the 3 as to be next or after, to be in the variable next to the head, which is the 2. Then after all of this, we just return inside the over here. Then over here we return head. Okay, so I hope this is clear. So what will happen right now is, okay, bear with me over here. Okay, so we said head will be 3. Now the third run, or the second, yeah, in the third run, 3, okay, will be the head. Sorry, 3. The head will be 2. Okay, but we will be on 3 now. 4. So now we are at 4. Okay, so at 4, the head will be 2, data will be 4. We will call the insert method. It would come here, head as 3, sorry, head as 2, data as 4. It would come here, create a node with the 4. Nice. If head is not none, yes, head is not none. So it go else, current is head, which is the 2. It would come check. Okay, alright, 2, 2, the node which has the data 2. Do you have next, or is it none? It would say yeah, I have 3 after me. So it would come, okay, next. Okay, alright, now we are at 3. So then with the 3, do you have something after you? 3. So it would come here with the 3. Do you have something after you? But we haven't implemented the 4, we haven't added the 4, so this would be null. Okay, so it would say no, there's nothing after me. Okay, so it would go break the while loop and come here and assign the 4, which is the here assigned here, to be the number or the node after the 3. Then we return the head, which is basically the 2. So I hope that's clear. Just as a recap, okay, so this is the head. We will start, if I okay, get the eraser. So we'll start with something like this. It would look something like this. First we come and check, okay, do we have a head? No. Okay, we have those like numbers as input, 2, 3, 4 and 1. So we will need to add those to a single linked list. So we'll check first. Do we have a head? No. Okay, so take the first number, 2, create a linked to create a node and make it assign as head. Nice. Okay, so then check if there is something, if there is anything assigned in the next variable in your node, in this node. So it would say no. Okay, if there is nothing, okay, let's assign the 3. Okay, so now yo2, there's a number after you called 3. Okay, now if you come and check with the head again, you would ask, is there something after you? It would say yes, there's the 3. You would come to the 3. Is there something after you? It'd say no. So yeah, there's an empty space over here. So we're gonna create and assign it to the 4. Now the 4, there is nothing after it. So we'll come to the 4. Okay, alright, 4, is there anything after you? It would say no. So we're gonna say, ah, cool, let's assign the 1. Then the 1 is the last number. So we'd say, if there is anything after you, it would say no, but we have added all the numbers, so we're cool. So always the last number in a linked list would point to none. Okay, the last number in a list points to none. The first number in any linked list is called head, and each number in a linked list called node. So let us run the code now. Nice, sample text code passed. Let's submit the code and see. Perfect. Congratulations guys, hope you've enjoyed the video and learned a lot. If you enjoyed the video, don't forget to hit that like button, and see you in the next one. Peace out.